right, so again, starting with today's presentation, this course is going to take a look at some of the workflows in AutoCAD Civil 3D that will use corner models to create complex surfaces, basically using them to solve some geometric problems that I've encountered helping some of you out with your modeling here at NV5. I see a few of you online will probably recognize a couple of the models because they actually came from a couple of projects down in San Diego. One of my examples is a subdivision grading plan from a project that I did years ago in Colorado, and there's just kind of revamped the process for Civil 3D corridor modeling. And then I also have some of my custom subassemblies I did was for a water tank project here that the Sacramento Water Group is doing. So definitely look at some real-life examples here. What I hope you will learn and what you should take away from this class, four main elements. One is to kind of take a different look at subassemblies, not so much in terms of road design, kind of think in terms of how to use them to solve some of your grading problems and look at them with a grading perspective. We'll look at how to assemble them into, or that's probably the best word to use, but create assemblies with these different subassemblies to attain some specific design objectives. We'll also look at using conditional subassemblies to help you build slightly smarter corridors, and I got a couple examples of that. And then last one, we'll look at just some of the benefits of using custom subassemblies to solve, in this case, I'm going to actually solve some real basic grading problems with those, and we'll take a look at those in the final section. All right, introduction of myself. Hopefully all of you know me. I'm Dave Zvislin, CAD manager here at NV5, where I provide CAD support, training, development of applications, workflow development, and also software consulting services. And I don't know if any of you know where that, but I have from time to time provided some of these training and support services to some of our clients outside of NV5. And then the last thing I'll just point out is this is going to be my 13th year teaching at Autodesk University, so I must be doing something right because they keep letting me come back to teach this. First section, we're going to just kind of do the 5,000-foot view overview of the different topics we're going to look at. I'm going to start off kind of with a broad look at just some of the grading tools available within Civil 3D. And I've organized them in a chart based on what my design objective is on the left and what Civil 3D object to use on the right. And I've kind of started out real simple with the Kogo point as a single spot elevation all the way down to the last two rows in the table, which is where the corridor elements fit in. And I'm going to use these. We'll see today that we use them for areas where I have multiple parallel linear objects, modeling grade breaks, such as our parcel model, walls, curbs, ditches, even a roadway is a grading model where we've got lots of parallel elements. The last row in the table here is talking about more complex models where the geometry varies as we move down the length of the model along the alignment or along the corridor. And that's where we're going to take a look at some of the conditional subassemblies will help with this, and also some of the potential enhancements that you can provide with custom subassemblies. So let's first look at just some tips and tricks, things to keep in mind as you apply corridors to your models. And these apply both to road design and grading design as well. Okay, the first and foremost, learn to use the help document that Civil 3D has for all of the subassemblies. In this help document, you'll find explanations of all the parameters available for each subassembly, what their behaviors are going to be, and then at the bottom of each one, there's going to be a chart and a image showing you all of the different code names and terminology assigned to the points, links, and shapes of each subassembly. Okay, you can get to this very easily either by right-clicking on an assembly in the tool palette and selecting the help option, or you can also get it through the subassembly help button that you will find in the assembly properties and also the subassembly properties commands. All right, definitely learn this document. If you don't know what tools are in your toolbox, how can you do the work? All right. Second thing I'll suggest is whenever possible, use the stock subassemblies. It's interesting because I've seen on some of the discussion forums where people need help with these custom subassemblies they're building, and it's like, why are you going through all that effort when you can combine a couple of the stock subassemblies to accomplish the same thing? So really assess before you go and make a custom subassembly, is there a stock subassembly that's going to meet my needs? And I think in most cases you're going to find that there is. All right. Skipping around just a little bit, one of the things I've recognized is that as I transition from region to region in my corridor model, it helps to have common points that line up from assembly to assembly. And I hope my picture here explains this a little bit. I've got a model here where I'm going from a flat pad area that then transitions into a retaining wall. And one of the things I found is that along this flat pad here, instead of extending the assembly all the way out to the end with just a single link here, is that I've put in a segment, as an assembly segment that corresponds to the width of the wall. So that way when I build my surface model from this corridor, I get a much cleaner transition from the slope because I will have a point here on the flat slope that will then correspond to a similar point on my wall. So you can see I get a nice edge of wall modeled here. And that's whether I'm going from a slope to a wall, or we'll look at our grading example later on, when I'm going from different lot types. I find that if I have subassembly points that correspond as I go from region to region, I can get a little bit cleaner looking surface model out of that. All right. Another thing we're going to look at in the example where we use the conditional cut fill subassemblies, one of the things we're going to see with them is that they are only able to test the depth directly above or below the insertion point of that assembly. An example we're going to look at later on is we're going to go from the top of a retaining wall, and we want to do a 10-foot wide slope at a 2-to-1 grade, and we want to know at this point, are we in cut or fill? Well, since I can't tell my conditional subassembly to look at a 2-to-1 slope, what we're going to do is we're going to offset over 10 feet. Then we're going to do our 3 conditional tests. And then at the end of that, say we meet this condition here, we'll use another assembly to offset it back 10 foot, and then we'll continue on with the model. So we're going to offset over 10 foot and then go back 10 foot. And the way I do these offsets, I find it's real nice if I actually model them with generic links, subassembly type. Usually I do the width and grade. Seems to work best with a grade value of 0. And then I can either go right or left on the side, or I can do positive or negative widths on that. And I can use that to offset over. And then what we'll do is there's an option to omit the link. I can't highlight that, but we can omit the link, and that way it will appear in the assembly while we're building it, but it will not appear in our corridor model. And we'll take a look at that in a little more detail when I get to that exercise. All right, oops, I had little graphics that show how it will then offset over and come back. All right, a couple other things we're going to see in terms of building surfaces from our corridors, that if you have any vertical or near vertical elements like walls and curbs, and in this example I have a V-ditch in my model, that if you build your corridor surface using top links only, depending on the spacing of your surface, it may not triangulate correctly. It's going to triangulate closest points. So a lot of times what I'll do is, in addition to adding surface data using just the top links, I will also add in the feature line data along the flow line or the top of curb or whatever, and that way you'll see then we'll get a real nice clean model through this area here. So there's something to kind of keep your eye on. It's usually going to happen around curved segments in your model where you have steep elements, face a curb, ditch slopes and things like that. So you just kind of keep an eye on that. Another thing you have to watch out with that is not all of the sub-assemblies have code names at those locations. And a good example of that is the side ditch assembly, which I've used in some of my models. It does not have any point codes assigned or code names assigned to the P3 and P4 points. So what I will do is I will actually use a marked point subassembly, and I will insert those at these locations, and I will give them a unique code name that I can then use within my corridor model to extract feature line or add these elements to my surfaces as feature line data at these locations. So use mark points quite a bit to add in any kind of custom point code that can also be used in cross sections when you're labeling, and you can put in specific codes for elements that you want labeled in your cross sections. So kind of keep in mind that you may have to supplement your model with some of these points. One last tip that I will point out here in kind of the general stuff is that I use surface labels to check my model. An example we'll look at later on is when I'm grading my subdivision, we have lots graded from one street to the toe of slope, and then from the street above we'll grade out to the property line, and then I will just let it interpolate the triangulation between the two. Well, I need to make sure that my slopes here do not exceed my design criteria. So in this case I had a 4:1 maximum slope that I could have, and you'll see all of these are flatter than that. So I got 4:1, 5:1, so there's nothing steeper than the 4:1 value here in this image. So great tool. You can grip edit these, you can move them along, you can drag them, and get real-time feedback on how your model's behaving. All right, so that's kind of the 5,000-foot view. So let's drill down now and look at some of the examples that I've put together just to demonstrate some of these concepts. All right, the first one I'm going to start with, courtesy of the folks down in the San Diego office. This is a building pad model where we had a bench mid-slope that we needed to have at different grades than the pad itself. And this was done to accommodate some of the drainage criteria. So here's kind of an image showing that. So our model criteria is we needed our slopes to be at 2:1. And then we needed a hinge line along the pad that corresponded to the way we wanted the pad to drain, or maybe it's a parking lot that you have maybe some ADA requirements, whatever. We could build that and control that with one alignment and profile. And then we needed to have a variable grade bench that accommodated vehicular access for maintenance, and then also there are several inlets located along that bench that we needed to have positive drainage for. And the example I'm using is I'm putting in a 1% slope. The problem we ran into then is how do we go from this slope here, the top of the slope, down at a 2:1, and where does that intersect these 1% grades along this bench? All right. The first attempt, we tried to do it initially with just the grading tools, and then with grading tools you have feature lines and you have grading objects or slopes. All right. The way we built it is we did a temporary slope of, or a temporary surface model of the 2:1 slope coming down. We can apply a style 1/10 of a foot contours, so these are 1/10 of a foot increments here, and then to get 1% we knew we wanted to start here, and then we just drew at approximate kind of eyeball using our status bar 10-foot segment lengths, and we drew this feature line down the edge of the slope here. Gave us an approximation of a feature line with a 1% grade. Once we got that digitized all the way around the perimeter, we used the step offset commands to create the ditch and the edge, outer edge of the bench, and then we were able to use the slope commands the grading commands to create a slope down to existing. Built a fairly decent model, but the problems we had with it is we found, boy, we made changes to anything, whether it was the original pad elevation or the pad grade, or we needed to move some of the inlets on our bench. We basically had to repeat this entire process, and it was fairly cumbersome to update and continue along the model. So we looked at then corridor modeling. What can we do to automate some of this? So again, looking at the corridor help document, studying all the different assemblies that are sub-assemblies at our disposal, we came across the link slope and vertical deflection subassembly. And the way this one works is it will calculate the horizontal distance based on the slope value and a vertical deflection. So we can say I want to go at -2 to 1 with a vertical deflection of -10 or 10 feet down. It will then calculate out that I need to be 20 feet away to get that slope. All right. Another benefit of this, if we look further in the help, we'll see that the vertical deflection value can be generated at each section from a target profile. So that will then allow us to profile the bench, and then the slope will automatically adjust the width to accommodate the elevation of the bench. All right. Real neat tool. We're going to hopefully see that in production. All right. I have a little video I did to kind of show the overall workflow here, just so I don't have to take you through every step within Civil 3D. So let me get that started here, and I may have to pause. So we're starting off with our existing ground surface model. And then what I did is generated 3 feature lines to model. If that wasn't what I wanted to have happen there. So did 3 feature lines. Okay, so this is going to be a problem. So 3 feature lines to model how we want that to drain. So we have a reference point that we know our pad needs to be at, and then we're going to drain these to the south, to the left, I guess, in this image. And we built a surface model from that, so you can see there's the surface and the contours. I then did an alignment of the perimeter of our site, and then we project that up to get a finished ground surface profile from that. We then modeled a temporary 2-to-1 surface, and then from that I did a bench perimeter, or bench alignment, and then we then extracted elevations from that surface, so we had an idea of where our grades needed to be. And then we're able to assign the corridor to this, and then from that we could then finish and build our surface from that. So we're going to kind of take a look at that workflow. I'm going to kind of skip down to, and we're just going to look at the corridor portion of this. So let me jump over now into my Civil 3D here. There we go. So we're in our drawing. So in here we do have now our subassembly I've already built for it. So you guys don't have to watch me do that. And again, the key element is this first piece here, and we'll look at the properties for that. And we'll see that that is, if I can find my name here, so that is a link, slope, and vertical deflection. If I look at the properties for that, come on, there we go. We're going to see that it has a 2-to-1 slope, or 50%. The vertical deflection right now I have is just 25 feet down, and that's what's being used in the display here, just so I have something to look at. This is going to be overridden in the corridor model by assigning a target. Okay. We have link codes assigned. Pretty straightforward on how that's put together. For the rest of the model, I'm using just some generic link width and slopes to model the V-ditch and the bench pad. So I've got a 2% grade up, so my pad's going to drain back towards the ditch, and then it's finished off with a daylight subassembly, and we're just using the same 2-to-1 slopes, both cut and fill. All right, should all be in fill the way this works. I also have a second assembly that is just the slope, and this is going to be applied on the ends of the model where our slope is too short to reach all the way down to the bench. So on the ends, we're going to throw in a couple of sections, regions that have just the slope. All right, so let's go over and look at our plan view model. So I've already got the 2 alignments drawn. So this alignment around here represents the edge of my pad. Okay. I have generated a profile from the temporary model of my pad grading. And then I've also drawn in an alignment for the bench. And one of the things I try to do here is I try to put curved segments on my bench that correspond to the curved segments of my building pad. I've also added in a couple of PVI points here, or PI points, where I know I'm going to have grade breaks in my model, and we may have to adjust these, but I'm kind of trying to plan ahead here. So that way I can edit this alignment to match up with the slope, or with the location of the slope as generated by the corridor. Okay, so my first pass here, I think this is about approximately a 50-foot offset, just kind of eyeball to where I think that bench is going to be. All right, so let's come in and look at the profile. So for my top of the slope, we have a profile, and we just sampled that. If I select it, we'll see this is a profile. It's a surface profile sampled from my temporary pad surface model. So we can edit that if we want to change the grades of the perimeter of our building pad. Okay. And then in my bench alignment, I've got my temporary slope profile here, and then my existing ground profile just for reference. And what I did then is I used the layout tools and put in exactly how I want my bench to be modeled. So you can see I've got 1% grade down to my inlet, another 1% grade going back up, and then we've actually put in a curve here and have lined this in with the existing surface here so we can be able to drive vehicles on that. And then going to the other end, I have also my other inlet. You'll see I do have some drainage structures thrown into the model here just so we can use those for reference. All right, so we got all those pieces put together. Let's go ahead and assemble our corridor now. So I'm going to come in, I'm going to create a corridor, and we'll just call this scoop bench. There we go. And my main alignment now is going to be the top of slope alignment. And then the profile, I have just that surface profile that I sampled. So we're actually use that as the baseline for the corridor. So that's going to make it dynamic. If I edit the surface of how I want my site to drain, this profile will update, and then also my corridor will update. Okay, the assembly, I'm going to use the slope with bench assembly, and I'm going to have everything target the existing surface. All right, I'm also going to turn on set baseline, so that way I can get my baseline parameter window as soon as I pick OK here. So that'll pop up. So let me go ahead and set my frequencies. Fairly small model, so I'm going to get by with 10 foot on the tangents, 25 or 2.5 on the curved segments. I do want to come in here and I'm going to turn off profile geometry points because that profile we're using for our baseline was sampled from a surface. It's going to have lots of PVIs, and I don't want to have a section at every one of those, so I'm going to turn that off. So let me pick OK to that. Then I just need to verify my target. So we're going to see here that my daylight is targeting the E01 surface. And then my link slope and vertical deflection, I need to target the profile for the bench. So we're going to come here and click on the None field, and I'm going to select my bench alignment. And then I have my bench finished grade profile. We'll add that. And we'll pick OK, so that will now show up in my target list. We'll pick OK to that, and pick OK to that, and have it rebuild the corridor. All right. I will get a few errors because my corridor goes the entire length of the top of slope alignment, which exceeds the length of my my bench alignment. We did get some errors, so I'm going to go ahead and clean that up real quick just by doing some grip editing here. And I'm going to come around. I've done this a few times, so I know I want that slope to end up right there. Okay. Something weird happened there. I think I had an O-snap going on. Let me try that again. There we go. All right. I prefer working on two monitors so that panorama window doesn't pop up all the time. And I'm just going to pull this one back to here. We're going to edit that one a little bit later. All right. So now I've got my slope or my corridor occurring where I am in fill, and I know about where I want my bench to be. And what I'm going to do now is let's add in the other regions here. So I'm going to right-click, modify region, and I'm going to add a region, and I'm going to go from the end here, and we'll just put kind of eyeball about right there. I'm going to use the slope only, and I just need to make sure that that's target existing. So I'll put that segment in, and then I'll do one over on this side. We'll go from some point there to about there, slope only, and again I'm going to target existing, and then I'll hit enter a couple of times. All right, my frequencies are a little messed up on those because it is sampling everything, sampling off the surface here. And then what I can do now is using grips, I can modify and slide these regions along. And I'll just kind of keep pulling this back to here, and then I'll grab this one and then pull that down to here. And what I want to do is I want this toe here to line up with the toe of my slope here. So I kind of just keep tweaking them along. And I'll just leave a gap between those two. When I build the surface model, it will triangulate across that gap. And actually, I'll use that alignment kind of as a reference here. Okay, so that's pretty close. Now I may need to fudge with that. Again, it's surface modeling. It's not rocket science, so for right now, that precision is good enough. Right. The other thing I would like to do is, since I kind of guessed where my initial alignment was going to be, I need to come through and make some modifications to it to make sure it lines up with where this red feature line is, because that's where the assembly is calculating where those high points and low points are. Let me turn ortho off, and I'll just kind of eyeball and move these along just to kind of get it to line up a little bit better. Okay, so this one here, we'll just see if I can kind of pull that one in. Come on, there we go. And I just kind of eyeball and get that to line up best as I can. We'll grab that grip and put it on right there, and so on. So you kind of get an idea how we can go through and tweak and modify this. All right, so what I'll do is I'll get that lined up. So now I've got my alignment aligned with where the corridor is calculating where that toe slope needs to be at the bench. And then what I'll do is, since I've modified it, is let's go back and look at our profile here. And we'll see it's matching that much closer. But I need to go through and maybe do some editing here since we changed the length as I come in and grab that. And I kind of want to make sure I move this and not change my 1% grade. So I'll get that lined up a little bit better. All right, so I need to fix that, but that's fine, close enough. And I can come in and see that maybe I need to pull this back a little bit to see if I can get it to line up with that a little bit better. Once I've got my editing done, we'll come back to our corridor model, and I'll do it through Prospector here, and I'll just go ahead and rebuild my model. It will update, and we'll see again now. It may take a couple iterations to get your alignment and the toe slope to line up correctly, but it did all that for us. To help us see that a little bit better, let's go ahead and throw the surface in here. So I'm going to my corridor properties, and we'll go to the Surfaces tab. I'm going to make a new surface. And I'm going to use the top link, so we'll add that to my surface. And in case there's any overhang, I'll tell it to use the top links. And in this case, I've got some real long slopes, so I am going to tell it to treat those as break lines just to make sure it does triangulate correctly from top to toe on my model here. Then I'll add the boundary. Real quick, just corridor extents. For those of you in NV5, I am doing this in 2014, so if you're using some of the older versions of Civil 3D, you may not have that option. So I think it is in 13, but if you're working in 11, you may not have that. All right, so we'll click OK to that, rebuild, and we now have our model. And if we come in and zoom in and look, we'll see that the contours are wrapping fairly nicely. And actually, let me split up my viewports here. Just so we can see this in a little bit more detail, and use that one there. So I've got some 3D views of my model. So now we can come in. Let's do that. Back out a little bit. So anyway, so you can see now we've got our contours coming down our bench, and then they're tying in real nice. But this slope here is staying at a nice even 2-to-1, and it's extending out to where our inlet's located. Where this gets real powerful now is when we go to edit this. Say I come in and I modify my profile here. Maybe we want to go real steep, and I'm just going to really exaggerate this. So we'll pull this down. My corridor will need rebuilding. In real time now, it will recalc and slide that bench over as far as it needs. And I'll probably need to go back in, if I want these grades to be real precise, I'll need to go in and edit that alignment, drag it over to line up. But you'll see I'm able to now extend this 2-to-1 slope down. The bench slid out. Same thing, I can go back the other way. pop it up into the air, and again, rebuild my model. Okay, and that bench will now slide further up. So you can see, we are sliding this bench. The toe slope is not moving. We're not changing anything else. We're just changing where that bench is located along the model. So you pop it back in there and do one last rebuild. So that is taking advantage of some of the assemblies that are available with Civil 3D. So let me jump back in. I overshot trying to find PowerPoint. There we go. All right. So that's using stock subassemblies to model a slope with a bench. Next thing I'm going to look at is expanding on it a little bit and using some of the conditional subassemblies. And there's two that ship with Civil 3D, and we're going to start off looking at what's called a conditional horizontal target. What I'm going to do is show you a model I built for grading lots where we're going to put in different lot types based on the target polylines that are being found within the drawing. So this model, and I've kind of simplified a little bit for the presentation purpose, but this is a project I did in Colorado, and we did what are called overlot grading or rough grading plans, where we assign different lot types based on the footprint of the house that's going to be put in. And the intent is then we grade the entire site. We do establish our basic road grade, a common element through all parcels, and then depending on the way the lot is going to drain, we have these 4 different types. So type A is going to drain from the back of the lot towards the front, and then it'll just interpolate the slope from the lot above down to where we terminate this. A type B lot is going to split drain. It's going to go towards the back. Some states you can't do that, some you can, so don't critique the design, just look at it. We're just demonstrating the concept here. A G lot or garden level lot actually drops 4 feet down on this project, and that'll expose half of the basement of the house, so you can have a finished basement with windows halfway on the upper half of the walls that are exposed to the outside. And then we have a W lot, which is a walkout. In this case, it went down 8 feet, which will expose the entire basement wall on the back side of the house. So basically, you have 1-story house in the front, 2-story house on the back, and you can have doors and you actually walk out where it gets the name. All right, so that's the modeling criteria that we're going to use. All right, let's make sure I got the right slide here. All right, originally we did this without the conditional, is I would need an assembly for every combination of the 4 different lot types with different road types. Originally did this in earlier versions of Civil 3D, and it would take up to 51 different assemblies and 25 different regions to build this model. The one I'm going to show you now is able to, using the conditional horizontal target, get it down to 5 different assemblies, and this is mainly for the different roadway types, curb returns, cul-de-sacs, and intersections that I needed the multiple types. And then instead of 25 regions, I've actually been able to build this model with only 15 regions, and again, that's for the different alignments, intersections, cul-de-sacs, and curb returns. It simplifies the model because I have fewer regions, and we'll also find that using the conditional horizontal targets, changing lot types is going to be as simple as editing the polylines. If I look at my slides. So let me jump over into AutoCAD again, back into Civil 3D, and let me see, I'll open up my drawing for that one. One of my tests today for our session is, can I have 4 fairly good sized drawing open and not have Civil 3D crash? All right, so the model is going to open up here, and we'll talk, look at the different components here. So I'm going to start off, I've got my screen split in 2 views, so I've got a 3D view here of this site, and this model is pretty simple. I really cleaned it up just for demonstration purposes. It's got 3 alignments, so I've got my main one street coming in, the street coming down the cul-de-sac, and then another one going through here. I have divided this corridor up into different baselines for each alignment, and then I've also modeled the curb returns and intersections, I actually use the intersection tool. I have found, if you want an even quicker model, is don't do the intersections and then just end your regions close to each other. For a quick rough earthwork quantity, it still gives you a pretty good number. I actually did this model twice with and without the intersections being modeled to this detail, and it only made about a 1% difference in the total earthwork quantity. So if you want to build a quicker model, we can leave out some of that detail. All right, so that's the model. Here's the assemblies that were built. Okay, here's the old assemblies where I was doing it, where I had, a garden on this side and then a type A on that side and so on. So you can see I'd have all these different combinations. Well, using the conditional, I was able to create what I'm calling my super lot assembly. And so let me zoom in, kind of take a look at how this was built. So I'm going to start, we'll look at just the right side for now. So I built the basic road section, curb, gutter, sidewalk out to right-of-way. Okay. At that point, I've added in a conditional subassembly, and we'll look at the properties for that one. And what I've done is I've set the type to be target not found. All right. So I'm using some polylines in my drawing to say don't grade lots in these areas. If those polylines are not found, go ahead and grade the lots. So let me zoom over to plan view real quick here, and at this intersection here, and I've got these white polylines here on either side of my intersection where I'm going to target to that subassembly. So you can see as it goes around this curb return, it's not grading the lots into this area here because this is the side of my parcels. I want to grade from the front here, and I'm going to grade these from this side over here. So we use this polyline that says, hey, if you find this polyline, don't do anything, but if you don't find the polyline, then continue on. All right, so the next segment is just a simple link offset and grade, or offset and slope. So it's got a 50-foot offset to this point here, and it's at 3%. That is a common element to all of my lots, so that's why we're not testing for lots yet. We're just saying every one of them is going to do this. Then we get down to this location, and I've got 4 targets on here now, and all of these are set to be type of target found. So if you find, in this case the one I'm looking at, if you find the type A polyline, put in just a 3% grade up. If you find the type B polyline, put in the 3% grade down. If you find the type G, go down 4 feet and then go to the rear of the lot at 3%. And if you find the type W, go down 8 feet and then continue to the rear of the lot at 3% as well. Okay. I've kind of gotten lazy. The way I've done it here is all 4 of these potentially could evaluate to true, which means I'm going to get links on top of links. So I really need to be careful in that I don't overlap my target polylines in my drawing to make sure I don't get lots drawn on top of lots. You could get by with doing a cascading of target found, but change the types to not found. So I could do a found and a not found for type A. If it couldn't find the type A at the end of that one, I'd say, okay, do a found and a not found for type B and so on. So I can make it a little bit more intelligent. I just got kind of lazy. All right. On the other side, same exact thing. You have to watch because the assemblies I used do not have a side property. I'm using the offset and slope. And you can see it's just a distance and a slope value. If you select it and right-click and use the mirror command, they don't mirror. So I ended up having to draw them on both sides. Not bad. Once I've got the first one built, then it's just a matter of copying it, deleting the left side. So now I have an assembly that does the right half of my road. Did it again, deleted the right side. I've now got one that does left half of the road. And these are used when I go through the intersections. And then for the cul-de-sacs, basically the same thing, but instead of being anchored or being controlled at the center of the road, it's controlled at the edge of pavement where I have cul-de-sac alignment profiles created. All right, and then there's a fifth subassembly for the curb returns that does not do any of the parcels on it. All right, so that is the assembly. So for the model now, we have all of our different regions, and in the regions we already looked at the white polylines I've drawn for the don't grade lots here, target. I've then also created 4 different layers for the different types. So I've got one layer that is red, that's going to be my type A. I've got another layer that's yellow, which are my type B. And I've got a green one that's type G for the garden, and then the cyan one that's the walkouts. And I've actually used just the primary AutoCAD colors 1, 2, 3, 4, so I know quickly at a glance which type I'm looking at. And you just need to draw these to make sure they're within the offset distances specified in the target subassemblies. All right. We can do them by layer. I find that I have a little bit better luck doing these individually. So let's look at now how we apply these to our corridor. So I've already built the corridor here. I've got this one baseline or this one region here where we don't have any targets assigned. And what's real nice with the newer versions of Civil 3D is we can now do it by region, which makes this a much more visual process. I don't have to go hunt for these things. So what I'm going to do is I'm going to edit targets. All right, so as I move my cursor around in my model, we'll see it'll highlight the different regions in here. So I'm going to be modifying this region here. All right, so we'll pick on that. I take the time on my assemblies to name everything with good descriptive names. So I've got all my different types here, so we can see, okay, here's my conditional, no lot found on the right side. Let me scroll down and see if I got one for the left side. I don't have anything targeted yet, so let me go ahead and pick on that. In the targeting dialog, we can either do it by alignments or I can do it by selecting objects. And you can either do it by an entire layer, so if you've done a real good job setting this up, I could just go grab my polyline not found layer. Okay, I did not set mine up that cleanly, so I'm by layer. I'm going to do it selecting from the drawing. And I'm just going to come in and say, okay, for this region, I want this polyline here, so that way I don't draw any lots on this end. And then same thing, I've got one down on this end. I'm going to select just to make sure anything that will potentially impact that. All right, so let me go ahead and pick OK. Actually, let me do that while I'm here. Let's do the right side of my road. So let's go back up and look at my R lots here. And I want to look for a type A found. So we'll say, okay, let's take that one. Let's select from the drawing. And we'll zoom out and we'll grab this red polyline here. And okay, it will rebuild my model, so we can see now it added the type A lots here. I'd like to get those all the way out to my property line, so let me edit those targets again, and I'll scroll down and I've got a type A2 rear lot, a subassembly that I use. So all I need to do is come in here and select from drawing, and then I have polylines. These dashed polylines that I've drawn indicate where my rear lot line is, so I'll go ahead and select that. And that will now show up in my target list, and then pick OK. And that will then extend those all the way out to the rear lot. Okay. On the inside here, let's go ahead and do that. So I'm going to add in these B, G, and W lots, and we'll target the rear for those as well. So we need to again scroll down. So I'm on the left side, so my type B left, select from drawing, and I'll grab that one. And I'll do my type G, select from drawing. All right, if I'm not talking, I find this takes me about 2 to 3 minutes per region here. For this model total, it took about a half hour for me to go through and map them all. All right, so let me grab the G's here. All right, so I now have got my conditionals targeted. Okay, I don't have an A, so I'm not going to worry about that one. And then I just need to set up the rear lot segments so I can extend them to the back of the lot line. All right, and all of these are actually going to target the same polyline. So I got this polyline here. Okay. I want to point out that on the cul-de-sac, I actually broke these polylines near the mid of the cul-de-sac because what I found is if my target wraps all the way around, it would get confused and the rear lot would then get pulled over the wrong side of the cul-de-sac. So you do have to kind of watch how you break up some of your targets here. I wish there was a way I could map the same polyline to multiple targets simultaneously. So if anybody from Autodesk will ever watch this presentation, hopefully they'll get that, because all three of these are going to be the exact same polyline here. All right, so we'll go ahead and map that. So I've got all my targets mapped now. We'll rebuild our corridor, and we'll see now that all of our different lots now show up in the model here. So let me zoom in a little bit. So I'm going to start at my cul-de-sac here. So here's our walkout lots. They go down 8 feet. Then we transition into our garden level lots with a 4 foot. And then we come around, and now we've got our split draining lots where there is no slope. And in order to get an exact 2-to-1 slope here, one of the things I've done in the model is if we look where I've got the gap here, this is exactly 8 foot between the two. So 8 foot, drop down 4 feet, and that's going to give me a 2-to-1 slope. You'll also notice that it is sampling targets or sampling sections at the ends of my polyline. So let me edit my corridor model and show you where that is set up. So I'm going to go into corridor properties, and we're going to go look at the parameters and we'll look at the frequencies. And at the bottom of your frequency list is this option to add sections at offset target geometry points. By setting that to yes, you will see that I am getting a lot of sections here, but it is getting all of the endpoints of these polylines, and then also it's sampling at my rear lot lines. All right, I have a surface model going with this as well, so let me actually turn that on. So let me go through, there's my finish grade surface, and I've actually just got a no display style. So let me turn that on. So you'll see now there is that nice 4-to-1 slope. Okay. One of the things I want to point out here, let me make sure I'm in the right spot, is my rear lot transition isn't real pretty, and one of the tricks we found I can do is just come in and I can grip edit this rear polyline, maybe add a vertice, and I can maybe pull that out on how I want that to wrap, and then all I have to do is come in here, rebuild my corridor, and we'll see how the contours update, and do I get a little bit better model? Yeah, so now I can get these contours to wrap around, so I can kind of play with that, maybe do the same thing down here where I transition from the B's to the G's, or excuse me, from the walkouts to the gardens, and again, just kind of eyeball, where that lines up with the end of slope, hit the rebuild. All right, and we'll see again, see if I can get a little bit better looking set of contours there. I do have my slope labels in here so I can test and see as I move this along. So I go from 5-to-1 here. I've got one little steep there, so we're 3-to-1, so I probably need to pull that line back a little bit so we can go through and fix that a little bit later. But you kind of get an idea how this works. Where this gets real powerful now is once I've built the model, you're probably saying, oh boy, that's a lot of effort to map all those targets and put this together. But what that'll allow me to do now is I can go in now and edit my profiles and affect an entire roadway of parcels or lots just by editing the profile. And I'll let you know I did kind of cheat here as I'm going to edit a portion of my profile. It does not coincide with any of the intersections or the cul-de-sacs. If I do modify this roadway and it does carry into this intersection, I will then need to go edit all the profiles for my curb returns and the cross streets. But I'm kind of cheating in that I want to modify it so I don't have to edit the whole thing. So what I'm going to do is I'm going to take and just put a big hill in the middle of my road. Okay, so we'll pick OK. And what you'll see is that impacts, and I've got automatic rebuild turned on here, so it pulled up my roadway here, and then all of my lots adjusted, maintaining their relative geometry, and then this rear slope where it's just interpolating between the two got a lot steeper, so you can see significantly more contours. All right, so actually let me rebuild just to make sure it's fully updated there, get my feature lines updated as well. There we go. So I got my feature lines included in the model now as well. So real quick, powerful editing. Just go in, edit alignments, rebuild, and your parcels or your lots will all update. Okay. This is pretty steep back in here. So what we're going to do now is let's modify some of our lot types. So I'm going to come in. I'm going to change my rear lot polyline. I'm going to pull that back to here. And what I'll do is I'm going to shift my B lots to the north here. So I'm just going to pick on that polyline. I'm going to say get rid of that vertex. And maybe pull that back. I think I got a lot somewhere in there. I'm going to eyeball the 8-foot gap here. And what I'll do is I'll just take this one and then pull it around. There's my 8-foot gap. And I'm not going to worry about that it's not parallel. I just need to get the approximate shape. And if I want a true 2-to-1 slope here, I would just need to make sure that the distance between those two endpoints is 8 foot. And what I'll do is I'll come in and maybe pull this in and do that same bump out here to see if I can get the contours to wrap a lot nicer. And then maybe I'll do the same thing on this end as well. So I'll come in and say, well, let's get rid of that vertex. And then we'll pull our walkout lots a little bit further here. And again, get rid of that little bump there. And then I'll throw it in this area here. And again, I'm just kind of hurrying through this just to give you kind of an idea. All right. So now once I've got all my pieces put in, we'll come in now. So what we should see is this slope here should move up to here, and then this slope here should move further around the model here. So let me hit the rebuild button, and it will go through rebuild and update. And very quickly now, I've now got more garden level lots here, or more walkouts here, more gardens over here, and I've been able to pull this slope down. Okay, a couple other things I've done with this model just to kind of see how you'd use this more of an interactive design tool. I do have a volume surface created. So let me turn on the style for that. And I've actually got a solid fill. So it'll come in and it'll show me there's the reddish colors are cut, the greenish ones are fill. That's what it was before I did the edit. So let me actually rebuild it. And it will update now. So you should see that I get a much more green in this area here where I pulled it up out of the ground. It actually got some blank areas here where I pulled it above my ranges for that model here. But real quickly then I can look at that properties here, go to statistics, and there's my volumes. For this site, I go tweak a profile, rebuild, rebuild, rebuild. There's my new volume number. So real powerful way to model and edit a subdivision or site grading model. All right, let me jump back into the PowerPoint here. And all right, you can see I'm halfway through and I've already eaten up almost an hour here. All right, so definitely need to cut some stuff out of that. All right, next piece, conditional cut fill subassemblies. This is a project again from the San Diego group. It's 3-tiered retaining walls with a 10-foot wide bench. And one of the criteria is the top of the walls need to have nice undulating curves to mimic the horizon, the hills on the horizon, and then this model also has a ditch along the top. All right, we originally tried to do this with feature lines. Difficult to model the curves. We were able to do alignments and profiles, extract feature lines from those alignments and profiles, but it became real cumbersome trying to determine where the start and ends of these were. That's kind of what you see, the little red polylines sticking off is kind of our way to try to figure out where we were, but real difficult to modify and revise. All right. Going to quarter model, this is where we use the conditional subassemblies now. So we saw in the previous example, I used the conditional horizontal target where I had to go and edit the polylines to get the model to update. This one we're going to use the conditional cut or fill. We're going to have it look at existing and then based on these conditions decide, well, if it's in fill, just daylight to existing, put the ditch in, and then clean it up with another daylight. If it's less than 5 feet at this 10-foot setback, again, target existing, but then put in a ditch and then clean it up with a daylight. If it's deeper than 5 feet, we're going to do our 10-foot wide bench, and then we'll do the next tier of wall. And we can repeat this over and over to put in as many tiers as we'd like. But we're going to use this condition, or these three conditions here, to determine how to put this model together. All right. Real nice process, because all we will have to do then in terms of revising the model is edit the alignments and profiles, and we'll see that the corridor will update and correct automatically based on those changes. All right. A couple of things we're going to look at besides using the wall heights, using alignments and profiles to control the wall heights. Since all three walls are parallel, we're going to use offset alignments, so that way I only have to edit the main alignment and all three will stay together. And then in order to model these accurately, I did a profile for each wall, but in order to see how they look relative to the other two walls, we can superimpose profiles to place those into the model. All right, so let me jump back into my Civil 3D, and we'll jump into our cut fill model here. All right, so in our cut fill model now, first off, let me find my plan. So here's our site with our walls, and I have three alignments here. So the main alignment's the base of the wall, and then there's two other alignments for the other two walls. And you'll see now that as I pick on these, I don't get the same kind of grips, because these are actually offset profiles where I can actually grip, maybe I can grip edit that one, and you'll see I can stretch and change the offset. And these are neat because if I modify the first one, you'll see all three will stay together. So a real neat way to help me coordinate these. Okay. I then created a profile, surface profile and profile view for each retaining wall. And then in the wall's profile, I did a layout profile. So here's the top of the wall for the first tier. Okay. I can then take that, and if I want to see it in the other one, we'll look in our profile menu here, and there's a command here to create superimposed. And I will just say grab that profile, put it in that view. Because these are offset further and because it's this big C shape, I find that if I go from start to end, it loops back on itself. So I'm going to go ahead and just kind of guess that I need to go about 50 feet. So I'm actually going to shorten what I'm sampling to make sure I don't accidentally loop back and crisscross within the profile view here. And it's just because of the way the alignments loop back around on themselves here. So I'll go ahead and pick OK to that. It will add that to my profile view using the default style. So I'll just come in here and say, hey, profile properties. I've got a superimposed style will apply. So now I can see that profile. I can now lay out my top of wall for profile number 2, and then here's my third profile where I want to be real close to the existing grade, and you can see there's the other two. So I can kind of go, use those references to help me lay out these profiles to get that nice undulating look to it. All right. So that's our alignment and profile. Well, let's take a look at our assembly now. So here's the final assembly that I built for this model. And one of the things I do recommend is develop a good naming scheme. So I've got my 3 walls here, and then I've just numbered them top and bottom of wall, 0, 1, 2, 3, 4, and 5. And we'll see that as we look at the target mapping and the properties, we'll see that, okay, that corresponds to how I've named these. All right, so first one I put in is just a link with slope. Let me bring up properties for that. All right, and we'll see again that that's a link slope and vertical deflection, and I've just given it a real steep slope to model a near vertical wall. And you can change this if if you're doing any kind of crib wall, we could do a 1 to 4 or whatever, and we can tilt these or however we need. And then I've just put in a height vertical deflection value just so I have something to play with here while I'm laying it out. We're actually going to link these to profiles, so that's kind of irrelevant when you put in here. Then at the end of that, let me carefully pick that, I have a subassembly that is a link width and slope that's going to the left 10 feet, and then I've set the omit link option to yes. So this link will not display in the quarter model, but I'm using it to manage that offset distance. And instead of just moving the assemblies, by doing it this way, I can come in here and say, well, if I want 20 foot, it's real easy. I can click it. That's now a 20-foot offset. If I want it back to 5 foot, I can click it and bring it back 5. So it just allows me to quickly edit and control where these conditions are going to be located. So we're now 10 feet over, so I know at my 2-to-1 slope here I need to be 5 foot deep here. So I've got 3 conditions. I've got a fill condition that's going from 0 to 9999, which should be all my fill conditions. At the end of that, I've got another subassembly here that's taking me back the 10 feet, so this will line up with the top of my wall here. And that's going to do a target to the surface. It'll put in our ditch, and then another daylight just to clean up the backside of the ditch. Okay. If we go into a cut, we'll see there's going from 0 to 5 feet. It's going to do the exact same thing. So I was just able to take these 3 here, right-click on those, do a copy to, and place them up on this one. And then my third one condition is cut going from 5 to 9999, which should be everything. And then again, go back 10 feet so it lines up the top of the wall. And then on this one, we have a 10-foot bench with our 2-to-1 slope. And then we're putting in the second level of wall, and then just the pattern repeats from there. Okay. To do that, I've got this example. I've built it out to this location, and it's just as real simple as once you get the first piece done, it's a right-click copy to place it on the end of there, and then I can just keep repeating this, right-click, copy to on however many levels you need. Oops, I missed. I wasn't paying attention. All right. Anyhow, so you get the idea. I want to put it up on the end of that one. You can keep building these out, and I have seen people in the forums try to build a custom subassembly to do this that will have n number of levels, and it's like, why? I've never had an infinite slope. I can customize this based on what I need. Okay, to put in the final pieces, I need my third wall. It's just a matter of doing a copy to, placing that on there, and then grabbing maybe a ditch, and this got too much there, a ditch and a daylight, and doing a copy to and placing on the end there. So that builds out my final model. So that's how the assembly is built. All right. So to build the corridor model now, so let me come in. I'm going to go to my menu here. So we're going to create a corridor. And we're going to say this is our cut walls. Again, my alignment, I've got my 3 alignments. It's actually wall number 2, but there's alignments 1, 2, and 3. So I'm going to do the first alignment. And then for that, I've got my pad surface that I'm sampling a profile from. And I'm going to tell it to use my wall number 2 assembly. And I'm going to make sure all my targets, all my conditional cut fills, and all my daylights are targeting E01. And then we'll go ahead and set properties here. All right, so if I look at my frequencies, default for this one I've set to 20s and 5s. It's probably fine. And again, since I'm using a surface profile for my baseline, I'm going to set that to no. And then I'm going to set all my targets. I just want to make sure you can see I've got all my different conditions, and all my daylights are all targeting E01, which is good. And then I just need to go through my walls now and target the profile. So here's my first wall. I'm going to set it to profile. I'm going to go my first alignment and then my top of wall. And I just have to find my second wall face here. This one I'm going to use my second alignment, top of wall, add that one in, and then we'll come in and we'll do my third wall face to the third alignment, and I need my top, add that one in. All right, so pick OK, it will rebuild my corridor, and I now have a corridor model of my 3 walls. Let me just show that in the object viewer here. All right. I have it doing some odd point codes are being linked here, so I apologize for that. But what we'll see now, the conditional will work, so we'll see as we go along the top of the first wall, as long as that sample depth is less than 5, it's putting in just a link and then the ditch. Okay. As we come around, we get to these sections here where our cut value now is greater than 5, so we can see we're now getting the vertical link representing the second wall, and it gets a little taller as we come along, and that is now targeting that profile, and then that is going straight back. And then at some point, we're going to see we now get the third link where it's going to intersect or be deeper than 5 feet, and it will put in then the third profile, or the third wall segment following all the way around. These crisscrossing links is just I got in a hurry here, is if I come into my corridor properties on my feature line tab, it's connecting these generic P2 links. I'll turn that off. Actually, while I'm here, let's go ahead and I'll build the surface model for this as well. So we're going to add just the top links, and again, if I had any short grade breaks on here, I could add those in as well. And then make sure we have that, and then we'll just add our extents. Okay, and you see now I get real nice. You can see that real nice rounded shape in our model here. And the last thing I'll do is just show you again how quickly this or easily this is edited. And I'm just going to split this in a couple different views. Not that one. Come on. There we go. It's hard to see when you can't find them, so I've got a 3D view. All right, so you can see there's our corridor with the different benches, and what I'll do is a couple things we can do is if I edit the alignment here, so I'll grab the main alignment, and if I pull that in a little bit, and you'll see it'll pull the wall forward, and I just need to rebuild everything here to get it to update. So I can quickly move my wall around, and then in terms of the profiles now, maybe I'll come in and we'll edit the first profile here. Let me shorten the curve up here so I can edit that. And what I'll do is we'll grab it and just pull that wall up. Grab it again. Okay, we'll pull it closer, so we're going to pull this point up into here. I'll hit rebuild on my model, and we'll see everything updates and it recalculates and everything looks real well. Other things I can do instead of editing the alignments and profiles, I can also have multiple profiles. So if I come in here, I've actually have some alternatives here. So I'm going to go into my properties here and modify my targets. And I've got what I call my extra wavy profiles here. So I'm going to be wall 1, I've got alternative 2, I'll remove the first profile, and then same thing for wall 2. And remove that one since I'm there. I'll go to alignment 2, and then alternative number 2, add that one in, and then okay, and okay, we'll rebuild the model. And we'll see now just by changing my profiles, I can get a much different look. Let's see if I grab those, throw them in the object viewer. I don't have a style with shading. Anyways, get an idea of how that's going to behave. All right. I appreciate folks who are still hanging with me here. I'm going to go just a few more minutes just to wrap this up. The last section I have is talking about custom subassemblies, and I don't think I'll do the demo for this. I will just kind of go through the slides and then see if you guys at the end have any comments or questions on this. All right. When using custom subassemblies, a couple things you need to before you go through the whole process. First thing is, can it be done with stock assemblies? Going back to one of the first slides I had is use stock subassemblies whenever possible, right? So can it be done before you go through the effort of learning how to use Subassembly Composer and creating that? All right. If it's a static shape, there is a command to create a subassembly from polylines. So if you've got like a rolled curb subassembly that you need to create where it's always going to be the same width, the same sidewalk or whatever, you can create it just by drawing a closed polyline and defining that as a subassembly. If it's dynamic, then you need to use subassembly composer, which we'll take a look at. And then just a couple of things to keep in mind. When you create custom subassemblies, the subassembly composer builds what's called a packet file or a PKT file, and you need to make sure that that gets imported on all users' workstation that's going to be using this subassembly on this project. If not, Civil 3D is going to give you errors that I can't find the DLL file or whatever in order to build or rebuild that corridor. And so it does become a logistical issue in that you do need to make sure it does get installed on everybody's machine. All right. Some tips and tricks for that. Again, going back to my help reference, build your own help document. A lot of these complex subassemblies, I'll actually sit down, whether I do it in Word or AutoCAD or sketch it on a piece of paper, I will create a map on how the assembly or the subassembly is going to look, what are some of the prominent point codes on there, what are going to be the code names, and how is it going to behave, what are the properties, and so on. So I will map it all out similar to what their help documents, and that helps greatly when you get into subassembly composer to know how you're going to build it. All right. I also recommend for novices start with a simple subassembly, and my presentation's taken off on its own. There we go. All right. The sample I was going to show today is a real simple daylight sloped subassembly that I've made. The handout I've created for this class actually does have step-by-step details for doing this, but just keep it real simple. Right. Get good with this. You know, in this one I've got 6 different points. I've got 2 decision elements. That's it. Real basic. Okay. Assign code names to all of your points and links, but use the default code names, which you can learn from the help document. Right. If you have a subassembly that changes shape drastically from cut to fill, I do recommend trying to use the same point number, and I've got it highlighted here, where you would connect other subassemblies. So this is a highway assembly I did some years ago where in a cut condition we're going to daylight from here going up to put in the ditch. In a fill situation we want to daylight, and it's a deeper section, we're going to daylight down. But what happens is if I don't use the same number here, I may attach it to this location in the assembly, but then when my model, my corridor alternates between cut and fill, my daylight is not going to be connected to the right location. So by using that same point number here, I attach it in my subassembly layout, or my assembly layout, I know it's going to work when I alternate between cut and fill. All right, another thing I've learned is don't get lazy when you build this. I did an assembly that did a HOV widening into the median, and what it did is it figured out the geometry based on the right side being lower. If the left side was lower, we just put, everything was done with variables, and we just said, okay, if left side's lower, multiply them all by -1. Cross sections look good, but what happened is the feature lines, and then the picture I have here, when we use the corridor solids extractor, our geometry zigzagged up and down the road. So that's the model we got when we tried to do a 3D solid. So don't use -1. So we ended up revising it and actually redid it. So we had one that calced everything based on right side lower, and then if the left side was lower, we recalced it all again, so we could keep all of the left feature lines on the left side, all the right ones on the right side. All right. Some sample assemblies I've built, and I've only done a few. Again, I find I can use mostly stock assemblies, sub-assemblies, but a couple I've done. One is what I call my simple daylight, and the reason I like it versus the Civil 3D daylight assemblies, one, it has only 3 parameters. The daylight general subassembly has over 50 parameters, and then the other one I like using is the max width one that comes with Civil 3D, and I think that has 18 parameters. Okay, it's horrendous. This is real simple. Okay, the other thing I did with this one that you cannot do with the stock daylight assemblies is you can actually put in negative slope values. So in my picture here, you'll see, there it is. We're actually going in a fill situation here. We're actually going up at 5% or 20 to 1. to intersect. And as long as my target surface is steeper and wide enough that I can actually solve it, this works very well. So it allows me to go up in fill and down in cut. Another one I've done is a retaining wall subassembly, and this is a Caltrans retaining wall. And what we're able to do is actually take all of their wall parameters for the footing, which they have in the table, and actually incorporate those automatically into the subassembly using this nested if statement in a variable. So we're calculating the width here based on the height. So if it's greater than 10.75 or 10.25, use the 7 foot 2 inches. If not, check to see if the height's greater than 8. If not, check and so on. So we nested these if expressions in the false value here. So it evaluates the expression. If it's true, return this. If it's false, return this value here, and we could then nest these in. And we actually did this for all the different parameters, so you can build in some intelligence to your assembly based on your standards. The other thing we were able to do with this one versus the stock retaining walls is the retaining walls that Civil 3D ships with target surfaces. And this one was built to target profiles, so it allowed me to create a subassembly where we can do a top of wall profile and then also do footing profiles. So you can see we end up with, we can create these step footings that don't necessarily follow what's going on with the existing ground. Or this is actually, for this model, this is actually the baseline here was the existing ground, and then we did a separate top and then a separate footing. Okay, so a lot of power. This also allowed us to insert multiple walls. The ones that come with Civil 3D are really meant to be used like daylight assemblies. You put them on the end of the assembly, you target a surface, it finishes off your model. So you use that instead of a slope. Right? This one allows us to create, like the previous exercise where we had the multiple walls, I could actually do that with these Caltrans type walls, and I can control each one with its own alignments and profiles. All right, and then the third one I did is kind of an extreme example. It's a water tank design model that we did. Allowed us to put in all of the tank elements with their own parameters, so we could change the base elevation. So we can actually, instead of editing profiles, we can actually edit the elevation value relative to the alignment profile around the perimeter of the tank. We can actually sink it down into the ground or raise it and lower it. We could adjust the footing depth, the height of the tank, the slope of the roof for pictorial purposes, kind of played with a little bit. But then we also had different parameters where we could do a finished grade, where we'd actually do a profile around the perimeter of the tank, so we could put in grades for drainage and whatnot. Then with the model, all we had to do was move our alignment around on our site, hit the rebuild corridor, and we can then update the model. And this one's been embellished. We actually added a slope and then that Caltrans retaining wall around the side here. But allowed us to do some pretty complex modeling, but modify it rather quickly based on allowing us to evaluate lots of different design parameters. All right, so that's everything I intended. So I can see I'm about 20 minutes long here. There is a wrap-up slide where I can just go through and talk about the different, what we saw. So we saw how we could use just the stock sub-assemblies to solve a, what I call a complex grading problem where we had to intersect the 2-to-1 slope with a 1% bench grade. We used the conditional horizontal targets, saw how we could control lot placement in our subdivision surface model. We used the conditional cutter fill to control the different tiers of our retaining wall, and then just showed you some of the benefits and some of the capabilities that you can do with custom sub-assemblies. All right, everybody's still with me. Thanks for sticking around for the extra 20 minutes here. So it tells me I do need to figure out where the heck I can trim 20 minutes off this presentation. I may drop one of the models here, and that's kind of the feedback I'm hoping to get from you guys as you leave the webinars. Let me know this was neat. I'd like to see more on this. Get rid of this one. Spend more time on sub-assembly, on custom, or whatever, or what elements would you think the users or the attendees at AU in a couple of weeks would be interested in seeing? So again, thank you for your time today. Thanks for letting me babble a little bit as I kind of try to work out what I want to say here. Please take an extra few minutes to fill out the survey as you exit, and have yourself a nice rest of the day. Thank you.